One of the earliest areas of investigation into perception was sensation, the data-gathering aspect of the process. There were no good tools for exploring the mind, so researchers went for the most objective approach they could find. It wasn't very objective by today's standards, but it was better than staring into crystal balls or reading tea leaves. Sensation is the primary process of data collection. We encounter too much sensory information to process. To avoid being overwhelmed, we screen out much of it. Our aim is to hang on to the important information and discard the rest. We have 132 million receptors in each eye, continually feeding us input. But we only have 1 million nerve fibers leaving the eye. So of the 132 million streams of information, we need to condense or lose 131 million of them. To help us discard unimportant information, we use 4 basic principles of efficiency: separate systems, subsystems, ignoring steady-state information, and precoding. First, we have separate systems. Our visual system inputs and processes light. Our auditory system inputs and processes sound. Each is a separate system. The eyes don't process sound, and you can't see with your ears. Second, within each system there are subsystems. In vision there is a subsystem for form and detail, the geniculostriate stream. And there is another system to process motion and location information, the tectopulvinar subsystem. If you lose one, the other system can function without it. Similarly, the brain has 2 hemispheres and multiple lobes, and pain and pressure are separate subsystems of touch. Precoding is the third principle of efficiency. We have cells that respond to specific stimuli. Some cells fire when light is present. As long as the light is on, the on cells continue to fire. We also have off cells that give a brief burst of firing when a light goes off. And we have on-off cells that signal when light comes on, stops signaling, and then signals again when the light disappears. We gain a lot of efficiency from separate systems, separate subsystems, and precoded cells. These hardware built-ins provide redundancy, efficiency, and fast service. But we are not just hardware. We have software too. And our fourth principle of efficiency is a bias. We have a preference for being left alone. Once a foot has sent a message that is sitting on the floor, the brain doesn't want to hear anything more about it, unless something changes. The bias of ignoring steady-state information makes our lives much easier. We only have to pay attention to changes. If things are going along fine, we don't need any input. Only notify me if and when something else happens. We use this bias of steadiness to adjust to our environment. If you move to a noisy neighborhood, you might find it difficult to sleep, but within a few days it becomes normal. This is our preference for steady-state information. We like things that are steady. We pay attention to things that change. Another example is the eye. The eye requires so much blood flow that 2 vascular systems are used. One is behind the retina and feeds the lining of the eye. The other is in front of the retina. It's actually in the way. Light is blocked by it before it hits our receptors. If those blood vessels moved, it would be very distracting. But since they are a stable structure, we don't even notice that we're looking through visual dead spots. Our hardware and software work together to provide a highly efficient processor of information. We are able to collect a lot of data, sift through it, and discard what we don't need. Our systems and subsystems have backups, and our precoding wiring is a simple and reliable way to quickly adapt to our environment. And with our prejudice for steady-state information, we can direct our attention to more urgent needs.